And we are going to start a new chapter here, and that is thin layer chromatography. In the previous section, we have seen about the column chromatography, and we have understood the principle and the procedure to carry out the column chromatography along with the application, advantage, and disadvantage. In thin layer chromatography, we'll see about the principle, and then we'll see about the methodology, application, advantage and disadvantage over other TLC. So let us start the TLC here. That's called thin layer chromatography. So TLC is a form of liquid chromatography which have mobile phase as a developing solvent and a stationary phase, a plate or a strip coated with a form of silica gel. The analysis is performed on a flat surface under the atmospheric pressure and room temperature. So what is the principle? The principle of separation is adsorption. One or more component are spotted on thin layer of absorbent coated on chromatographic plate. The mobile phase solvent flow through because of capillary action and the component more according to their affinity towards the absorbent. The component with more affinity towards the stationary phase travel slower and the component with lesser affinity towards the stationary phase travel faster. Thus, the components are separated in thin layer chromatographic plate based on the affinity of the component towards the stationary phase. So we have already seen the principle in the introductory part of the unit where I discuss about that how does a compound which is going under the separation attain equilibrium between the stationary phase and the mobile phase. Based on the equilibrium attained, the shift towards the stationary side means if they spend more time on the stationary phase, they will be eluted later, and one which spend the time more in the mobile phase will be eluted first. And no two compound has got similar affinity towards the same stationary phase. So on that principle, the compound gets separated. So when we look into the other part, what are the practical requirement for the TLC to carry? You must have a stationary phase, you must have a glass plate, and then preparation and activation of TLC plate, application of sample, development tanks, mobile phase, development technique, detecting or visualizing agent. So let us see what are the stationary phase. So when we see the different type of a stationary phase used in this, the different stationary phase are silica gel H, silica gel G, silica gel GF, aluminum oxide, cellulose powder, polyamide powders, aluminum silicates, calcium carbonate, kaolin, kiselgar, magnesium oxide, powdered sugar, silica gel, starch, and talc. So when we look into the different type of a stationary phase, they are even modified in the existing or the naturally present silica, or they bring in a change depending upon the need of the separation. So we have a silica gel G here, which is mixed with a binder called gypsum and G with a fluorescent calcium sulfate. This are used depending upon the compound which you are going to have a separation. Well, apart from this, we have a preparation of chromatophores which the size are different. So the standard size of chromatophore, the length are kept constant, the only thing what are changing is the width. We have a different size here, 20 into 5 centimeter, 20 into 10 centimeter, and 20 into 20 centimeter. The standard film thickness is 250 micrometer, and method of application for absorbent is pouring, dipping, spraying, and spreading. So these are the different methods through which TLC plates are prepared. The more accepted preparation of TLC is a spreading method, and we have inspired a different method of preparation. So what do we do in pouring? When we prepare the sample through pouring, the absorbent of finely divided and homogeneous particle is made into slurry and pour onto the plate and allowed to flow over it so that it is evenly covered. In dipping, this technique is used the small plate by dipping the two plates at a time back to back in a slurry of absorbent in chloroform or any other volatile solvent. The exact thickness of the layer is not known, and the evenness of layer may not be good. So what happens when you are preparing the TLC through pouring and dipping? The biggest possibility is that forming of a lump. When there is a lump formation within the stationary phase, there is no proper separation. The movement or the migration of the mobile phase along with the sample is hindered or affected. So these are not generally accepted method of preparation of TLC. Apart from this, we have two more methods that's called the spraying and the spreading. In a spraying, what happens? The slurry is diluted further for the operation of a sprayer, but the technique is not even now used nowadays because of again the problem of getting uniform layer for NTLC is highly accepted. If there is no uniform layer, there will be no proper separation of a compound. So we have the other method, and well accepted method is spreading. In this, all the above method fails to give the uniform layers. Modern method utilizes a spreading device for preparation of uniform thin layer or glass plate. Commercial spreader are of two type, one moving spreader and the second one is moving plate type. It gives a uniform thickness layer of 0.2 to 2 millimeter. So depending upon the requirement, we can design the thickness of the stationary phase onto the glass plate. So this is how the TLC plates are prepared. The fold technique is discussed here, and the most accepted is, again I'm telling about the spreading method through which we prepare this. So what if we, after the preparation, you need to do the activation of plate. So what is activation of a plate? Activation of a plate is generally done to remove the moisture present in the stationary phase. So when you have a presence of any sort of solvent into the stationary phase, it will again affect the flow of the mobile phase as well as the migration of the compound which is under the separation. So make sure that it has to be activated. So how to activate that the prepared TLC? You need to keep it into the oven for long range of time or at high temperature for a small range of time, so that the present solvent evaporate from it. So at 60 to 65 degree it can be kept at overnight, and for at the temperature of 120 degrees Celsius or above this, it can be kept it for hour or together. So this is how the activation of plate take place, right? So what is the solvent system? Again, the solvent system in TLC is not universal. You need to prepare the solvent system depending upon the nature of compound. So nature of compound for separation decide which type of solvent system has to prepared. So the choice of mobile phase depend upon the following factor: nature of the substance to be separated, the nature of a stationary phase used, mode of chromatography, it is normal or reverse phase, separation to be achieved, analytical or preparatory. So we will discuss about analytical and preparatory in the HPLC section, which is not included in this unit. So the different type of mobile phase which is used for eluting out the substance is alumina. When the alumina is absorbent, it could be a petroleum ether, it could be cyclohexane, carbon tetrachloride, benzene, dichloromethane, chloroform, ether, ethyl acetate, acetone, ethanol, methanol, water, pyridine, greatest eluting power when the alumina is absorbent, and these are organic solvent. Make sure that this solvent is not individually used, it can be used in a mixture. So again I said that the mobile phase is not a universal, that you take an ether or you take an water or you take as a methanol. It can be in a composition, it can be in a composition is 95:5, 97:3, and the two solvent or three solvent can be mixed together to attain the polarity at which the compound can be separated. So the mobile phase preparation is a trial and error method, right? So we have to take in a consideration that which is the solvent system which gives the proper separation. We should not choose a mobile phase in which the solvent is in which the compound is migrating at faster speed or at the slowest speed. The main concern to choose a mobile phase is to give the separation. If it has got a proper polarity and then the separation happen, this is that is a more accepted mobile phase. So depending upon that, we design mobile phase on trial and error method. So make sure the area of application should be kept as small as for sharper and greater resolution. The meaning of this is that when we are spotting a sample in TLC, make sure that the sample is not spotted too much. And if it is too much, there will be tailing effect or there may be no proper separation. So the area of application of the sample must be kept small, and it must be diluted in concentration, not too diluted and no over concentrated, so that there could be a proper separation of the sample. The rest of this we will discuss in the next video. for TLC, that how the separation happen. So till then, take